All right, and then I'll share my screen. You see my screen?
Yep.
Yeah, so I don't know. I mean, you were all there in the previous session, right? So should we recap, or should I did want to go back to exercise number 1 with the hello world, because I think I was a bit too quick around it. So I propose that we start from that angle. Is that okay?
Yeah, sounds good.
So so there's a bit of a history, but I'm skipping over it. I added also a few slides that hopefully help with some of the concepts. So yeah, so the first exercise that we have is the hello world, right? Basically, if you look to what you need a few pieces of information to be able to run the project, right? So one is, given everything is API based, it means that you need somehow an API, or what we call in Kubernetes resources, right? So it's REST based, so it's a resource model. So you need a resource, which is an API object, right? And an API object has a schema and that you can use to do validations and stuff like that, right? And the second thing that you have is you have what they call a reconciler, or what I call a reconciler. It's basically something that uses or watches that resource, or a specific resource. So a reconciler is always focused on only one resource, right? And it then executes its business logic, right? Now, if we saw before, so I go back to the project, so the hello world. So this is my VS Code project, right? So if you look to the base project, is what you typically have is CRDs. I think I already showed that we can also get them through references, so you can actually import them, so you don't need to have them locally in your project. But in this one, I added the CRD local, right? And so these are customizable by yourself. So that's, I think, one of the interesting properties, is that you're not depending on a schema that someone has or built. Of course, you probably, so my view is a little bit, so you take what the community developed, and then you probably want to customize it a little bit for your environment if it doesn't suit the needs. Or you just use whatever is available. So you have the ability to customize whatever you want, right? And then, so what you also have in the project is then the reconcilers. And so I was trying to explain last time is that a reconciler has actually two aspects of it, or two elements attached to it. So the first one is you actually, so there is a config.yaml file, which basically explains or tells how the reconciler attaches to the system, right? So, and this is the resource. Then I created a slide for it just to make it clear what it actually does. Okay, so I added this slide. So why is it there, right? In the first place, is basically you have to somehow, I mean, if you go back to this picture here, what you see here is that, so these are your resources and your CRDs, if you will. And what the reconciler config kind of says is how it's basically the connection from the reconciler to the API server. It basically expresses that in a YAML file of how that connection looks like, right? And it's used for multiple purposes. So there is multiple parameters that are relevant here. And I think it's important to grasp them such that you understand a little bit why they are used. So the first parameter is metadata.name. So if you go to the YAML file, it's actually this name here, right? So metadata.name. And so this has to be unique system-wide. And why is that? Is that it serves as an identifier for that reconciler, right? And so the way the system is working, or what is the principle behind the system, is that you can have multiple reconcilers on the same resource and even resource instance, but a given parameter within the instance can only be, let's say, modified or mutated, or what I sometimes call that is can only be one authority for a given parameter within the resource instance, right? And so this name, so this metadata.name serves as the system-wide unique identifier to do so, right? So that means that, for example, and it's per parameter, so it's not per resource instance, it's per parameter in a resource instance. So that means that, for example, if you have a schema like here, I think it's greetings, right? So that greetings parameter can only be owned by one entity. Now, the interesting part is what do you do with dictionaries and what do you do with lists, right? So there it is such that a list, it is an entry within the list that makes it unique. So in other words, so one of the examples is a condition. So the condition list is actually a list. But so in other words, you can have multiple entries in a list. And so the way Kubernetes API server works is that an entry in a list needs to be owned by a given entity, but you can have two different entries in the same list owned by two different resources, right? So it's very flexible, I think, but you of course have to follow these rules when you design your business logic, right? And so this metadata.name, which you have in these reconcilers, serves as that unique identifier because we use what we call server-side apply. So maybe just to recap, I think we went through it. So there is two ways that Kubernetes offers to update a resource. One is what we call client-side apply. So the way client-side apply works is that the client does a get of the resource, it does its changes, and then applies it back to the system. The problem with that approach is that if you have two clients that update at the same time, they might create a conflict. So in other words, there is a reservation inside of the API server system inside of Kubernetes that deals with that. So every API object has what they call a resource version. It's maybe a little bit too detailed, but I think it's important to understand is that, so there is a resource version. So that means that if the first one updates it, the resource version is going to change. So the second one that comes in, it can be even a microsecond or something like that. You see that the second one does not succeed and it will get an error back. And as a result has to retry its changes, right? And it could be that someone else already did the job and stuff like that. Now we in choreo do not use it because it is very, let's say there is a lot of potential for conflict. So we use in choreo only the second option, which is server-side apply. And server-side apply is basically following the principles that I was saying, is that per parameter, and a parameter is either, of course, if it's a scalar, it's basically a single entity. So that is then providing uniqueness, or an entry in a list or an entry in a map and stuff like that, right? Or in a dictionary. So that's kind of, so what we use in server-side apply. So we use server-side apply. So in other words, the client, so you have basically segmented your system in a way, or you have designed it in a way that you say, okay, this reconciler does these parameters, this reconciler does these parameters. So you have to ensure that there is no conflict. And then what you see is that the way server-side apply works is that for every parameter that is modified or that someone modifies, it keeps a record of what they call a field manager. which is a unique identifier of that entity that owns or has the authority for a given resource. And so metadata.name is what I use inside of choreo to make that uniqueness. Is that clear, or do you have questions? If not, I'll continue. Right. Okay. So this has to be unique system-wide. If you look, I did some documentation on choreo. So here, so I don't know whether, did I share this already? So there is a, I documented, so there is a whole, let's say, guide on the user guide, but also developer guide, right? So I put this in the developer guide. So what you see is that it has to be unique. And what I suggest personally is to name those in such a way that you use resource name, group, and then a unique ID that you give. So for example, here I use Hello World, which is the resource name, then example.com is the domain, and then this is the unique ID. So if you take that convention, you always have, so what you have to watch for is that the last part of that name makes or is unique somehow, right? If you have multiple reconcilers in your project. Okay. The second thing that I did here is what is a condition type, right? So the way that Kubernetes conveys status, first of all, so Kubernetes did not really define rules around that. But what you see, all the projects somehow, or most projects, I have to say, are using conditions as a way to reflect the status. So in other words, when you indicate whether something works or does not work, you use a condition. And a condition, so if I run the project, you will see it in I'll get you some more details, has a few fields. So it has a type, which makes it unique. So which is basically, you could say it's the key in the list, okay? And so the typical usage of a condition is a ready condition to indicate I am ready or not ready. And so a condition type has a time. So the time when it got changed, it has a reason, and it has a status, and it has a message, I think. But the status is basically a Boolean, which is true or false. So if it's true, it means the condition is met. So that means, in this case, if you have a ready condition, it is indicated as being okay. So I've done the job. And so I try to institutionalize that thing in all the resources in choreo, so that if you define a resource, that you always use conditions as a way to indicate your status. Now, given that on a given resource, you can have multiple reconcilers. So in other words, on Hello World, in this example, I only have one. But you will see, I think, I'm not sure whether I have it here, but you could have two reconcilers on the same resource and resource instance. Okay, that means that if both of them, so I want both of them to indicate that condition, so they cannot use the same type, because then the key would clash, and then also the server-side apply would say reconciler one use ready one, let's call ready, and the other one also ready, and it will clash, right? So that's why the condition type is there, or is exposed, to indicate uniqueness. You need to have a unique condition type for that reconciler, but that doesn't have to be system-wide. That is within this resource identifier that it has to be unique. Okay. The third thing that I expose is, and I did that for the time being, just as a way to maybe we have to put some authentication or authorization rules onto it. In most cases, a spec you don't update, right? But in Hello World, I, for example, update the spec. And I don't know whether it's a pattern, but I said, okay, in most cases, it's just you do the thing, you get a job, and then you convey another result, you create other resources and stuff like that. And so I was not sure that every reconciler has the authority to update the spec of a given resource. And as a result, I expose a Boolean to indicate that. So if you don't put this to true, and you will see if you return a resource, it will be updated in the system. If you do not put this in true, it will not happen. That means that even though you return a change, so choreo will not take it into account. Okay. And then, the other parameters, I will go into more detail. So you have what I call the for resource hook, the own resource hook and the watch resource hook. So in Hello World, we only use the for resource hook. And so the way I try to explain it is in this way. So a for resource hook, you always need to have it. So it's a must, but you can only have one. So that means that but you can have multiple reconcilers on the same resource or resource instance. Okay, so it means you could have a second reconciler that does something else for it, right? And so what you have to do if you have multiple on the same resource is what I call here ensure parameter authority. It means that you have for a given parameter a single authority that takes care of that parameter, and that you don't have reconciler A on parameter A and reconciler B on parameter B, and they both update. Then you will get errors from the server-side apply system to say, hey, there is two reconcilers that are trying to update or have conflicting information on the same object. Okay. Now, if the parameter, for example, if he does parameter A and he parameter B, right? That doesn't matter. So even if he changes parameter A, the server-side apply will never use parameter A when he applies. So he just basically the way the system works is you can almost say it masks the update with that parameter because someone else is busy with it. So that's how the system works. So when you apply a new resource and he was already updating parameter A, parameter A is kind of masked, even if so he should not set it, but if he did not change anything, he kind of masks that update, and only parameter B will be updated. So that's how the system works, right? So that's why I keep saying a given reconciler can only be, so the authority of a parameter should only be with a given reconciler, right? And then, of course, what will happen is every time a resource changes, for example, if they both work on the same resource, they both get an event to say, hey, something changed, and then they do that logic, right? So that's how this works. And that's basically how a for resource is operating, right? So if you want to see that in action, right? So as I said before, I think I already put, so this is the code spaces that I showed before. So I'll start the server, right? Like I did before. If you do choreo run, I was playing a little bit because I just started it. So if you run it, you get a result. If you go, for example, choreo CTL get hello world, right? -o YAML. So now here you see the conditions, you see? So the conditions is a list, and it has a type which comes actually from here, right? So this is the type. The status is true, means it is okay. It has a reason, so I just copy it if it's not okay, and then a message, which is a string. And this is typically used to indicate additional information. So if you return from the reconciler an error, you will see this being conveyed in this message, right? And you also get a time when the transition, so the last transition time is when a change happened on that particular condition, so you can see which when what happened, basically, right? So that's where this condition type is used for. So if you have two reconcilers on the same resource, you might have an additional entry here, but that's why the type here should be unique per reconciler that acts on a given resource. And that's in order to ensure that the rules regarding server-side apply are met. Okay, I think that was the piece that I did not explain enough, I think. But any questions on Hello World? If not, I'll jump to the next one.
I think I missed why do you use ready here for the condition type?
It's to indicate that the reconciler was successful in doing its job. Right? So okay. If you build a reconciler, it could be that you get an error, right? Now in this code, there is no such thing, but in theory you could, right?
Yeah.
So the way so if I see an error message being returned, I actually watch that, and depending on the error, I basically indicate an error in the reconciler logic. You see?
Yeah. Okay.
That's where it's used. So you see, I don't know. Wait a minute. Which one? So if you look in topology, the reconciler, there is only one. So here you can have an error, you see? So if, for example, I try to create a node and it did not succeed, right? I will return an error here.
Mm-hmm.
And then I know something went wrong. So why could you get an error? For example, the schema that you try to update was wrong, right? So that's a bug in the code, basically, but that's okay. But you still, you want to get good debuggability when something goes wrong, you see?
Yeah. Okay. Yeah, makes sense.
Yeah. And you can also, so there is two types of errors. One is fatal and the other one is an error because it could be, for example, that you did not yet get, let's say, take an IP address, for example, right? You want one and you didn't get it yet. So then it's okay, I reconcile again, right? So you can retrigger. So not all errors are basically fatal. So you can also indicate one versus the other.
Yeah, okay, thanks.
Okay. Yeah, so the Hello World was basically a way to to just explain, but yeah, so there is a lot going on under the hood sometimes. Yeah, so the topology is just, yeah, it's a different example. And what is the difference in that example is that basically the difference is between the Hello World. In the Hello World, I update the spec. In the topology example, I generate new resources from the top resource, right? So you get into, so that's what we call inside of the config.yaml file, what we call own resources. So it's resource. So in this example that you will see, that we'll go through in a bit, you have a topology file. And I always try to make the analogy to container lab somehow. So basically the idea here is basically I get a topology CR, we'll show in a bit. The reconciler does its thing. And what he does, based on the content, he generates new resources or updates the resources if they already exist based on the information that he retrieves from the original object. So the difference here, and what you will see inside of the reconciler, is that you see that in the config.yaml file, I now also convey own resources. Okay, and so why is that the case, right? So in other words, this reconciler, he gets some information, he does its thing, and then it generates additional resources. So in this example, it's a node and a link that is being created or updated, right? Now, what the system does, so why do you have this own resource hook, right? Is if someone would delete this resource, there will be a trigger to the reconciler. So the reconciler not only gets triggered for the resources, for the 4 resources, if you will, But he also gets always informed if a resource that he owns, that he created or updated, so he is responsible for, the reconciler also gets triggered. So you get an event, and then he goes, so it's idempotent, so he goes back to the same loop, right? And you will see in a bit, there's a third resource, which is a watch, which is basically something the way I try to explain it, he is dependent upon, so his business logic depends on that resource. So as such, so that's why there is the distinction between for, own, and watch. So the distinction is a for you always need to have, and you can only have one. So there is no, so every reconciler needs that. An own is optional, and this basically is indicating a resource that you own. And also what you see is that when I after the run, I show you all the dependencies and stuff like that. So there is an object inside of this owned resource, which is what we call owner references, which points to this resource instance that generated it. That is the owner of it. And that's how the system then knows that a new event or an event gets triggered if something changes and stuff like that, right? Another thing that you see, and at the moment, I always edit in choreo. So if you look back to the hello world, you see I did not explain that properly. So I also add a finalizer to the object. And I also use that metadata.name. So the same, I'm in the wrong one here. Yeah, here. So I use the same name as this one as the finalizer. So a finalizer is an indication in the object to say, I need to, when you delete the resource, I still need to be involved to clean things up and stuff like that. So that's what the finalizer is about. I always generate them for every reconciler, whether you want, I need them or not, because I don't see, it doesn't harm if you don't. But for example, if someone deletes a resource and there is a finalizer still on, it will not get deleted. It will only get deleted when all the finalizers are removed from an object. So that's what its purpose is. And the reason is that it is it's an indication that that resource should not just be deleted from the API server, but there is still a cleanup action to be done, potentially in order to for someone to do something with it. For example, delete additional resources that were depending on it. That's typically what you see happening in this environment. Okay, so yeah, okay, yeah. One more thing. What you also see if you look to the code here. So yeah, so maybe we should go through the difference. So like, yeah. So with respect to reference, so in this case I use. Wait. So I'm sorry, I'm in the wrong one. In the moment I use references to get the CRDs. So that's basically what's happening here. You also see in upstream references, there is two types. There is one that are only there to import APIs, and there's others which actually import a whole project. I'll come back to that in a bit, but so in this case, I take the CRDs from a Git repo, right? But if you look to the reconciler logic here, so first let's go to the config.yaml file. So again, this is the same name, so nothing changed here. Here I use link node ready, and the reason I did it, I think, is because I took it from KubeNet, and there I have multiple reconcilers on the same resource. So yeah, I changed the name here from ready to this, but you have the choice. So in this case, it wouldn't really matter. And then I have the for resource, and I also forgot to explain this, is that you can have selectors on that object. So in other words, in this case, the selector is, I don't care, basically give me everything, right? So that means that every instance of that resource, this reconciler is triggered upon, but you can also indicate, and I think we'll see that in the next example, you can filter. You can say, I'm only interested in objects with these parameters, right? So that's what the selector does. In this case, it's give me everything, right? And then there is the owns, which is basically the objects that he potentially can generate or update, right? So this is basically the triggers or the resources that he is entitled to generate or to create based on this input that he gets, right? So that's, so you see here that you get children. Sometimes I call them children, but I use the terminology that is in the controller runtime code of Kubernetes. So I didn't try to come up with new terms. So I just reused what they have, right? And then what you see in this example here, so the code is a bit more involved. So let's maybe also look at the inputs that I'm going to use in this example, right? So what happens here is I look through these nodes, right? So I just look at spec and then get nodes, right? So I look through these, I build a node object from it, and then I do client create. So this is a call or a built-in function, as I call it, that choreo exposes to the reconciler. And what it does, it basically allows the reconciler to basically say, this is a new object, or this is a resource that I would like to be in the system based on this input, right? Now, at this, when you do this call, choreo does not yet apply it to the system, but it basically puts it into a cache, if you will, right? And you can have failures on it. So if you have a failure when you do so, you will, I'll return an error, right? So then the code here will stop, right? If this succeeds, then you walk through the links, which is basically this object. And I will build a link resource, and the same happens here. So you have the same client create built-in function that is being called. So basically you say, I want these resources. Now, when you call reconcile result and it succeeds, what choreo will do, it actually will look at your existing resources that you had created before, and he will take care of all the updates, deletes, or creations based on the existing system. So in other words, what I try to do is simplify the logic that you have to build as an automation engineer to the bare bone, right? So in other words, when you do this, even if there is 10 resources that were created before, and we will go through an example of that, I'll do the cleanup and the modifications of the deltas are taken care of for you. And the reason I did that is to ease or simplify the logic that you as an automation engineer needs to develop. That's the whole idea, right? And to reduce that to a minimum if possible, right? So I think that's basically the explanation for the most part. Yeah, so I did own resource, yeah, own references. Yeah, we didn't do that yet, so I'll show that in a bit. And then built-in function, yeah, so we use the built-in, the client create is basically saying, yeah, based on this information, this is what I want to happen, right? Any questions on this? Okay, so let's maybe just run through it. Then you have a view on. Yeah, no, I don't have to open. So I just start the server. Let's maybe walk through the README. quickly. So I think I introduced all of this. So we use references. So the way, so you see here, I prepare already the directory, but it's not created, right? It's only when I do run once that you see I start cloning the directory, right? And to your point earlier, then I think you asked the question, you see here I clone. So this is actually a clone of the Git repo, and then I take the reference out of it that that was there, right? So here you can now, so this succeeded, right? So what you can do now, for example, is do what I call depths is dependencies. So now you see here this topology object, which was my input, right? Which was this input here. I am generating a link object because there was only one, right? And I generate two nodes, one with node 1 and one with node 2. Okay. And so you can also do a diff. So you see here, I do the same command, and if there is a plus, it means it's an addition. So this resource was not yet into the system. So I added it, and if you do a diff minus a, you can actually see a diff with the pluses and stuff like that, right? I think there is still a bit of format I have to look at to see that there is a better thing here, right? But so I'll try to give you a bit of information on the changes that have happened from the and this is against the previous run, basically, because I create a snapshot every time you do a run. I create a snapshot so that you have the ability to go back and forward to. I then get so try to work on the developer experience somehow. Okay, now one of the things that I was so one of the things that we did not do, so if you do get nodes minus o YAML, for example, so you see here you have now owner reference, and it refers to the topology resource with the name KubeNet, and this is the UUID, right? So if you take, this is the, so we can, if you go and you look at topology and minus O YAML, and then grab, I think UID, you see that this is the unique ID that is coming from the topology resource. So the way I can understand the dependencies between all of these resources is through the owner references. And these get set. So when you, in your config.yaml file, when you basically indicate, I own these things, and actually, to be honest, I don't really need this, right? Because actually this client create actually tells me what it is about. So I am looking to see, maybe I can generate some of this config.yaml file. I cannot generate everything, but I think the owner things I could easily generate from the code because I know which resources you're going to create, right? So I could simplify that a little bit. So that's something I potentially can do to simplify the job even more. But so, yeah, so it's basically every client create that you do is kind of an own resource, right? And these are the ones on which I put that owner reference. And as a result, I can look at the dependencies and stuff like that, right? Now, for example, in this mode, so one of the things that which we did not do, right? So for example, here, if you apply this, then what I'm going to, and I think we did it last time, right? So you could apply this to the system, right? And so what you see here is that when you apply to the system and I'm not in a continuous running mode, I actually update the file not in the database, but actually on the input resource. So you see that I actually changed the file that was here, right? And if you now run once, if you run again, you see that I actually create additional resources, right? Curiosity, run once, right? So now what is going to happen is that I'm generating, and if you, if you run depths now, so you see that so this is dependency, so I created the additional resources. If you run the diff, you see that this means nothing changed. Wait, no, so this means it changed. Wait, so this one means nothing has changed, right? This means it got deleted, this one got added. So you see that I changed, so I try to indicate which resource changed or not, right? Based on the indication that you see here, okay? And then you can do -a, and then in a big file, I need to do some filtering here to make it simpler, but you see what got changed, the plus and the minuses and stuff like that, right? And so if you then, for example, I think we were doing that before, so maybe only do node 4, or let's say delete node 1, which was already there, right? And if you do this right now, I think, if you run again, I think I'm generating a failure, right? You see, because the reconciler logic, so you create a link on a node that does not exist, so the reconciler, so this is, for example, a failure that I return in this code here. So here, so this is, for example, an error that I return here, and you get then the indication that was in, and I think here I need to put a space. Okay, I just see. So this is, for example, an error that I generated or I indicated from here. And if you look right now, if you look at get topology minus YAML, you see you get the same message here in that object. You see, and that's an error that was coming from here, because this code checks that a link object in this resource has a corresponding node into the system, and if it's not, it will create an error. That's what this thing does. So yeah, so in other words, you see that there is even code that so you get errors based on your business logic and stuff like that. And so now what I have to do is basically delete everything where node 1 was. And here, right? So the rest stays. Yeah. I do it straight into the, okay. I did it straight into the input. So if you run again, right? You see, if you run deps, you see that I cleaned up node 1, I cleaned up the links and stuff like that. You see, so the system takes, you did not have to write the code to say, is link this one there still or not, or I need to update this and that. So the code that you have to write is, the way I try to explain is, you only have to basically tell choreo, these are the resources that I want based on this context. And that's all you have to do as a logic and the whole idea is to simplify or ease the amount of code that people have to write into the system. Okay, so that's topo. I think then we go to the next one, which is actually the most interesting for most people, I think, for now. But I think it's important to get to the basics, right? So that you have a good understanding of what's happening under the hood. So in this example, I have a bit more, so there is more code, right? And there is more logic. So first, let's go through the reconcilers here. So the first one that I have is, so this reconciler, what it does, it looks at the node object, unfiltered. It creates an IP claim, so it basically generates, or it will request an IP address from the system. And here it checks whether the IP index that I need to do the allocation exists. And here I use filtering, you see? So if only when this resource exists with this name, right? And if it's ready, so that's the ready status. So here I'm checking the ready condition type, and the status is true, only then I want to be triggered, right? So that's a little bit more advanced, but if you look, that's kind of the most complex you have to write at this stage. And then in this code, I'm basically generating the IP index somehow, right? Yeah. The second reconciler is, so here it looks at also the node, right? And here it also, so here you have a match condition to say, was the IP claim that this guy, so here the IP claim is a condition of this reconciler, and he only generates the IP address, or he is only interested to look at the node object when the IP claim condition is ready. So don't bother me as long as you didn't get an IP claim. You see? So that's kind of what is happening here. So we created like a dependency between this reconciler and this reconciler because they both act on the same node object. So both of them use node. But the way we use dependencies inside of choreo is using these conditions as well. So you can, and that's also how Kubernetes does it. So you kind of can say, if you have an entity that needs to be finished before, what it says is you look at the condition or the ready condition to basically indicate, hey, did I complete my job or not? If not, don't bother me, but only when you're complete, I'm interested to do something. You see, and that's how you can build dependencies between different objects, but still have this independent, complete independence of how you operate. Okay, which I think is a nice property. And then what this reconciler does, it creates interfaces and sub-interfaces based on the IP address that he got, right? And yeah, so that's kind of this one. And then these are interesting ones. So these are the ones that, because the interface and sub-interface is what I call abstract device specific configuration. So, but in an abstract way, so they are vendor agnostic. And what this reconciler basically does, it actually, so this is again the same logic. So it uses condition type ready. It looks at the interface objects, and it only, so here is, I also use a filtering to say I'm only looking at as a Linux box. So if I get an interface for Arista, I'm not interested, right? And then he generates a config, which is an SDC config, using a Jinja template that is here, right? And for the sub-interface object, it's the same, right? So here it's just sub-interface. I forgot to add the selector here. So actually there's a bug, or it's not really because I only have one at the moment. So but that should change to also care only about as a Linux things. And then I use this template, right? And so what happens basically is he gets this abstract device configuration or sub-interface configuration in, and he generates a vendor agnostic configuration. He generates, sorry, a vendor specific configuration for that particular object using this resource. And then I think Vanessa alluded to it. So I'm also, when you run the reconciler here, I use two flags. So the -A and the -S, I think, right? That's the one out of the top of my head that I use. And so what they do is, because we are doing this config generation, right? And if you generate a config, so at the moment we are very focused on Yang. So what we want to do is also check whether it is aligned with the schema, right? So when you do the -S option, which is the SDC flag, what is happening under the hood? Wait, so this is topology. That's the wrong one. Here, this with me. So basically, so wait, so I run the -R and -S. Yeah, I thought I was wrong. So -R is basically it's injecting the IPAM allocation and stuff like that to the system, right? And the -S is actually running the SDC side. So what I also created a slide for what the SDC flag does. Maybe let me go one by one through it. So -R is injecting the IPAM system. The watch resources, and I alluded to it. So this basically you can also watch resources you are depending upon, because they contribute to the system. And I think I forgot to explain that is there is another built-in function called a get. Did I put it here? So there's a few built-in function. Yeah, get resource is get resource and client get. So you had client create and client get. So these are built-in functions that you can call, that I expose to you for you to use if you need that logic. And a get is basically, it's I help. So I help you to get access, and there's also a client list to get access to resources that are in the API server. So you can just fetch them easily. And I do that in order to get access to the IP index, for example, I think. Yeah. So that's so there's a few additional built-in functions that I am checking or that I'm using. And then yeah, so the other important thing is that what you see in this resource is I added right now a Yang schema, and this is the same resource that you would in the config server of SDC you would use there. So it's exactly doing the same thing. And I am going to fetch the schema from the Git repo that are referenced here. And they are being locally consumed in this case. And then what is happening as well is that, so the SDC flag, so I load the schemas. And then for each node in the system, so I locate the schema. I take the running config. So the other thing that you see in this project is that I have running configs for the devices that I fetched from a node, right? What I'm doing is that I add the additional configurations that we generate using the business logic. I apply to the running config file that I got. I do the validation. And then I generate, if everything succeeds, I generate a new full configuration with the changes. So let's do that. And you can ask questions in the meantime if there are questions.
I have one question. How did you fetch the run configuration? Did you do it manually?
At the moment, I did it manually. Yes, I did it manually. Okay. And this is a discussion I would like to have with all of you, is to see how you would like to see that happening, right? Going forward, right? So it's how I believe we have to fetch it from an API server somewhere, right? But yeah. So at the moment, what I did for the time being is I fetched them manually.
Okay. That's good.
And I just, at the moment, the way it works is I put them on the running configs. So in this thing, and I use the node name that you have here. That's what I did, yeah. And at the moment, it's a JSON file. I can also change it to YAML, but that's typically what you get from the boxes. So I took whatever they gave. We can change this.
Oh.
If needed. Yeah. And then what you see is, so this succeeded, right? And then what happens is, if you look to the data, sometimes I look to the database, because what's most interesting is look at config here. So this is actually the configuration with all the changes. So if you now do a diff, and now I need to look into which flag I added. I added the flag minus A and minus C, I think, yeah, minus C. So now I see that the config on node 1 got changed. So minus C I added because I do a special thing. I just look at the running config that you add into the system, because that's your base. And then I do a diff between the newly generated. And if you want to see the differences, so you see here, these are the, and I need to look at the formatting a little bit better, but this is actually the diff that that this project has on top of the running config. So here you can see the diff, and if you're happy with it, then you say commit, and then you actuate, right? So, but the idea here is, or at least the thought that I have is here, that we stop at at the moment we generate a configuration, and then someone can look at, are these diffs okay or not okay, and if so, we can do something with it. Yeah, 1 second. Does that make sense? Or
yeah, it makes sense.
I still need to do a bit of the format.
Make it
Sorry, yeah, go ahead.
Sorry, yeah, it makes sense. It is a good idea to make diff. Yeah, in my opinion, yeah.
Yeah, the idea was always my goal or my thought is, if I go back to this slide here, right? So this we didn't go through it today, but I want to build these decoupled systems. So this may be too complex, but so if you look to choreo, it actually sits here, right? And then I have a provider or an actuator, as I call it, and that could be Argo or GitOps tools, but that can also be, so I'm planning to build like a transaction one that acts here, and then it goes to SDC, or you could use your own tools to apply the configuration onto the system, right? But so so the idea is that you have something that generates configuration, right? You have something that applies them to the system, and then something, yeah. So basically, I want to build components that you can pick and choose, and yeah. It's not one big thing.
So where you have runtime here, this is where you see SDC sitting, I suppose.
Correct, yeah. So this is where SDC then would sit, yeah, correct. So there is this actuator, which I don't think we don't have really at the moment, unless you basically go straight from here to here, right? But today we use like GitOps tools to do it, like Argo or Flux or config sync. But I'm planning to build an actuator which is doing the transaction, because you don't see that in the GitOps tools. And it's not a lot of work, but I first want to finish this part here. And the first thing that we have to actually do is make the interface from SDC similar to what I use in choreo at the moment. And we don't have that. So at the moment, I apply all these config snippets individually, right? So I think we had that on the Discord a little bit. But the problem is that at the moment, I generate the big configuration, let's call it the full configuration, but I lose at the moment the context of how the configuration was assembled. So in other words, at the moment, I cannot say this parameter got changed based on this CR or this sub interface resource. And so we are going to, so Marcus is back by the end of the week, so we are going to fix that. So that's the first thing that we have. And then we can actually, if you want to use SDC, even to the device, we can actually say or tell you this parameter on the configuration got changed based on this CR, and we can have the reverse tree all the way back up. So that's the first thing that we will do. And then once we have that, I'll build an actuator, which is a transactional one, that basically does the change network-wide. Because what you see in Argo, they have rolling updates and stuff like that, but they are not so good in transactions at the moment. So we'll add a transaction actuator that uses that new interface.
In the actuator layer, do you see there being some kind of way to review and maybe approve the change?
Yeah. That would happen before even, right? So what you see in choreo right now, it generates config, right? I'll be able to give you a diff, and then I think it goes. So there is a Git backend in choreo. So the idea is you check in, right? So the idea is you do a PR, right? So the idea is to add a PR, and then once that gets approved, then the actuator kicks in. You see?
Yeah. Okay. So you might see actually choreo being used locally, I guess, right? To actually output the configs and then commit them to Git.
I even see choreo potentially being used as a GitHub action.
Yeah. Okay.
But you can also use it as a developer tool. So I think I wanted to make it flexible that. But if you have something where your business logic is solid, right? You run it just as a GitHub action, and it just I think is the easiest, not?
Yeah. It makes sense. Yeah.
And then sorry.
Yeah, sorry, I just had one more quick question about the how you generate the actual vendor specific config. So is it a hard requirement to have the Ginger 2 templates? Or
No,
it's possible to
no,
do
it's a choice. So all of these things are optional pieces. So if you don't do the SEC flag, yeah, then it doesn't run basically. So if I run without the SEC flag, right? Yeah, wait, so sorry. If the SEC flag does do the validation and merging the configs and stuff like that, but if you can remove this logic here, right? So you can, if you say I don't care about the vendor specific, you just don't have these reconcilers into your project, then yeah, then we only do abstract.
Yep. Okay. Clear. Thanks.
Yeah. Yeah. So if you would remove these reconcilers here, you would not. I only generate the abstract configuration. Right. So it's fully customizable, I think. But yeah, or at least that's my ambition.
Can I ask one question to the abstract configurations? So we do have the abstract configuration, and then the abstract device configuration, and then at the end, what we want to apply on SEC is the specific device configuration, right?
Yes, correct.
Okay. Could you explain a little bit more where you would see the abstract device configuration?
I do it like that at the moment is not go straight to the vendor, is because if you change at some point, let's say you change from vendor A to vendor B into your network, you can use it so all the upper level stays the same, and you only change the template or whatever. You can also use Python script, by the way. You can use other logic to do the conversion. So in other words, you don't have to use it like that, by the way. So you could use it completely differently. But the way I was thinking is that if you generate to an abstract device configuration, that means that all your upper layers from there, you can stay the same. And if you then introduce other vendors, you only have to change the lower part. You see?
Yeah, yeah. So, but to have like image in the mind for to see where exactly the abstract device configuration is, where exactly would it be here in choreo?
Yes. Yeah, I have it here. So if you look at this here, so here you see BFDs, BGP neighbors. In this exercise, we didn't use them, right? But in this exercise, we use interfaces. So these are your abstract interfaces that I generated. You see?
Yeah, yeah, I do. Thank you.
And here there is sub interfaces. So these are the abstract APIs that are vendor agnostic. But for example, I have a provider in here to say this is who is going to implement it in this context, right? But you see here the IP address being used, right? If there would be IPv4 and stuff like that. So there is some indication of platform type and provider into the system to indicate the potential vendor. But this, if you have Arista, it will translate to Arista. So this is a generic field, if you will, right?
Oh, okay, yeah.
But these are the very abstract things, but they are not so, I mean, yeah. So you see, this is a routed interface. This is the IP address, right? So for the interface object, you get VLAN tagging, right? Whether it's there or not, right? So it's which MTU you use, right? So it's, and here it's the IP address, I think. No, it's also MTU. So basically it's, yeah.
Yeah, that's good. Perfect. Thank you.
Yeah, so you have all of them into the system. So interface, so under device, network kubenet.dev is the abstract. So that's how I designed the APIs. So device, network kubenet is the abstract models. And then config is the specifics. You see? But for each, you see here, for each interface that you saw before, I now have a vendor specific. You see? So I translated it to the vendor specific So this you can transact to the with SDC to the box, and this is a vendor specific interface. And then here you have the one with the IP address. So this is actually as a Linux terminology, you see, whereas this, I don't think you can apply to any vendor. This thing.
Yeah. Okay, looks good. Thank you.
Yeah. But they are all generated into the system, and you have access to APIs and stuff like that around them. And you have here, I also have in the meantime ISS and OSPF and stuff like that. So I'll add them to this project as well. But so, yeah, so these are the vendor agnostic ones. All right.
You get schema cloning the repos, but why you don't get it from struct for the devices?
Say again, Evgeny?
I'm just saying that, yeah, I saw you get the Yan schemas cloning just upstream repository, but why you don't get schemas out of the device direct?
Okay, because I could, but in choreo, because it's not really connected to the device, I got them via the internet, right? So it's the easiest way to get, because then I'm independent of the infrastructure, you see. But that's an option as well. I mean, I could get them from the device. I just need to build a plugin for that. But yeah, so yeah, it's possible. Yeah.
You have to extra check that is a correct Yan model you get.
Yes, but for example, what you see is that all the vendors, they publish them, right? So Arista, Cisco, Juniper, we, Huawei, Chena,
Sure.
we all public, even Sonic, they're all public.
Yep.
So it's the most generic way at the moment, Evgeny, if I'm honest. That's why we picked this one.
Okay, but comparing to the OpenDLI, they was taking them all.
Yeah, and ODL, they took it from device. We can also do that, by the way. But this at the moment, this allows us to use it offline or with a device or not, you see. So it's a bit more flexible for us at the moment.
Sure. I got it.
Yeah. All right. So that's what I had for now. I think, yeah, I would love for people to play with it and get some feedback, and then we can maybe touch base early next year, right? And then we'll be in touch.
Sure, we have a good homework for the new year.
Yes, yeah.
Tim, would it be possible to get hold of the slides?
Yes. I will share straight after the meeting. Yeah, I'll share on the Discord. And
Great.
yeah.
Thanks a lot.
And also the recording. Yeah.
Yeah, thanks a lot.
All right. And yeah, if I don't see or hear you, probably not see. Happy Christmas and Merry Christmas and Happy New Year for all of you.
Same to you.
Yeah.
Yes, thank you.
Yes.
Yeah, thank you. You too.
Yeah.
Bye.
Bye.
Bye. Have a nice evening.